more complex polygons. But to start off, I need everyone to stand up first. Come on. Come on. Wait, no one. There we go. All right, now sit back down. Okay, so we're going to play with some complex polygons.
Father Donald needs your help. He wants to build a pig pen for his new pigs, and he wants a fence that has side lengths of 6 feet, 10 feet, 15 feet, and 15 feet. So with the mock fences that we have, we'll call them poly strips, we want you to see if you can create a pig pen this size.
And you can use the fasteners to put them together in order to make the shape, okay?
From one dot to the next dot will be a foot. So.
All right, here we go. You can talk during this too. It's a collaborative effort. Here we go. Each dot represents. You don't need to move
What was that? Yeah, fasten them together.
Are you guys okay? So these ones should have somebody else.
Yeah, this one's
And you could be completely right too. Here we go. Alright. So how is that creating the polygons? Someone messed that poly strip. Huh? The dot is supposed to be where you're putting the poly strips through in order to create the fence. The dot actually represents a fence post.
How's it coming out? Yeah, looks like it. Oh, sorry, it's okay. Do I have another one? Which one's this side? What side's this? Oh, I don't know what that is. This is the side. Wait, I'm just going to okay, so you need 6, 10, 15, and 15. Oh my god, you're trying to I'll just let you figure it out. Yeah. Were you making a triangle? Okay. Why is that? What are you wearing? I can see that though, because it's we are on the one line. Yeah, so I didn't do the 6, I was doing I did that in there. Okay. Okay, so which side actually? Okay, so if you were to fasten these, could they move around and they stay stable or stay stationary?
What about on the other side and to the nurse?
It's going to be a trap over there.
Are you winning?
What?
Are you
I know it's out of the triangle. So now I'm on the right hand.
See, a triangle is a kind of polygon, but a different one than we're doing right now. I'm going to take this away from you now. You tell me, how many sizes this one? How many this one has? This one has? This one has? Move. It's not your
It works, but it's just like not.
It all depends on how you create it. Well, I mean, it all depends on how you create it. And also, you had like more of these than other people did. Because, sorry. shape that is?
Quadrilateral.
Does anyone's look different than that? Oh, can you hold up yours again and see if it compare it? Does anyone's look, I've seen some yours, it doesn't. Lindsay's? Lindsay's looks different.
All right. So now we're going to create a different quadrilateral using these dimensions. He wants to make a pen that has sides 3, 5, 10, and 20. Now let's see if we can create these using the poly strips.
It's easier, you're not fast, and you can like
Yeah, you can just lay them
lay
on
it on
top
top
of
of
them.
each other. Eric was pulling them, so if that helps, that kind of was a good idea.
We need to use stronger paper.
Yeah, yeah, that's a good idea. Like punch holes or something.
Or use laminated.
You are old. She's like, stop it. Where's your break? Is it working? Does it seem to work? Why do you think it works?
Is anyone having trouble or?
What do you guys find about this shape? Does it work?
No.
Why do you think it doesn't work?
The length side of 20 is too long for the other side to reach the end of that fence.
Okay. And how can you compare this to the last one then, in relation to side lengths? Like, why does that one work and why does this one not work? And think about like the last lesson with the triangles.
Actually, Matt, can you share with us what you said to me earlier?
I was building it, I didn't think it was going to work because I used my prior knowledge when I learned about triangles to estimate that this wouldn't work.
What was that prior knowledge?
Because the two short sides need to add up to be as big or bigger than the largest side, and 3, 5, 10 added up to 9 plus 1.
So it wouldn't close, right?
Right.
All right, so now you guys are going to come up with your own set of 4 numbers and see if they work with the poly strips. You're going to come up with one set that will work and one set that won't work.
So create them in your head, just like think of numbers, and then create them with either the person next to you or the partner group, depending on if you're working in partners or not.
And keep in mind what Matt was just talking about.
Cool, you can think of numbers for it now. And you think of it, yeah. And make sure that they would fit on the poly strips, like number-wise.
Yeah, don't go above 20.
So nothing above
That won't work out very well. And use different numbers than the 2 sets of 4 we already gave you, because that's kind of cheap.
Okay, once you have your 2 sets, trade them with someone around you.
If you did them with a partner, trade them with the table next to you.
And then, now that you've switched, look at them and determine if you think they would work or would not work just on looking at them without using poly strips. And then try to prove it with the poly strips afterwards if you can't tell or can
Did you guys trade with your people who traded numbers?
Yes.
And remember, don't use the poly strips to test it out at first. You're just trying to fuse the theory that Matt talked about. Which one would work? The daily?
Oh, yeah, because I like what mine is.
Great job, guys. No, they're supposed to, like, you know, but it's okay. Yeah. How do you know that this one would work?
Neither did I, but I'm not.
What about this one? What makes you think that one wouldn't work?
No, but I didn't know she was.
So would that polygon? How do you know it works? But this one's why not? The next one is that this one is Alright, so is everyone sharing with a pair around them?
Can someone give us an example of sides that would work?
Lindsay, how about you? What is a pair of sides that would work?
10, 10, 12, and 12.
Okay, and how do you know that would work?
Because that means there would be two opposite equal sides, which means it would be a rectangle and it would close.
Oh, rectangle, very nice. Tori, what is a pair that wouldn't work?
5, 3, 2, and 17, because 5, 3, and 2, and adds up to 10, and it's not greater than 17.
Alrighty. And now, the whole class, what do you call a four-sided polygon?
Quadrilateral.
Very good. Okay, now, can you make a quadrilateral with any four sides? Thinking of the lesson we just went over. And why not? Because you spoke up, I heard you again.
Because I think there was a triangle, or that's not quadrilateral, but the trapezoid, the three smaller sides have to add up to be bigger than the fourth side. And those numbers don't work out that way.
Alright. So now, what would the side lengths look like for a rectangle? Lindsay, you shared earlier, so how about you say it again? Thank you.
I did. It would be two opposite congruent sides. So to have two sides of equal sides of opposite.
Okay, what about a square? I know this group over here did a square. What do those sides look like? An example would be... Very good. And how about a parallelogram? Taylor. Your nose is in the air, so I thought you knew the answer.
Parallelogram has two pairs of equal sides, right? I don't know. Yeah, it has two pairs of equal sides.
Alright, so what would an example of a parallelogram be for side length?
5, 5, and 10.
Very good. Alrighty, now what you guys...
What if I put those not across from each other?
If you didn't put them across from each other, can anyone tell me what it would look like if you didn't put them across from each other?
And would it be a parallelogram?
Alright, so now I want you guys to create any kind of polygon, any kind of quadrilateral you want. Alright, any kind of quadrilateral you want.
You just never answered.
Just make sure the sides are connected.
There's one that I have. No, it's not.
What would it be?
Alright, now with that quadrilateral, I want everyone... With that quadrilateral, I want everyone to take another poly strip and connect the two corners. Connect two of the corners of your quadrilateral with another poly strip.
You don't have to fast forward now.
Yeah. It doesn't have to be a fancy quadrilateral. It can look like however you want. Okay, so when you connect those when you connect the two corners, what do you see now? Two triangles. Now, will all quadrilaterals have two triangles in them if you connect the diagonals? Chris, come up here and demonstrate for me real quick. Huh? All right, Chris. Now, can you break all of them up into two triangles? Are there two triangles there? Okay. All right, so can we come up to a consensus that all quadrilaterals can be broken up into two triangles?
Yes.
Can we come to a consensus that all quadrilaterals? All righty. So now how does this relate to the previous lesson?
Concave.
Are you disagreeing?
Yes.
Yes.
How are you disagreeing?
If it's concave and not all the points are on the outside, then it might not be two triangles.
Can you break that up into two triangles? Or try? Just try. Connect two of the corners. Would you be able to?
No. Yes.
Wait, I don't think that's the corner though. That's like the concave. That's still very severe.
I'm just gonna keep going.
But no, Lindsay, you brought up a good point. So that would only work for what kind of quadrilaterals?
On that. It's regular.
Okay, so now how can this relate to the previous lesson? TJ?
Two triangles. Make it quadrilateral.
All right. Matt, you connected to the previous lesson earlier. How did we connect this lesson to our previous lesson?
On the triangle, the shorter sides have to be greater than the larger side, so I guess in a quadrilateral, the two sides that make up a triangle must add up to be greater than the diagonal.
All righty. Now, could we all agree that that's a rule too? All right. Thank you. And not if you agree.